Hey, good morning, everyone. So, last week I had the opportunity to share with you kind of one of my aha documents that HyperLedger has out there on their Read the Docs. And I've had a couple of requests to kind of just walk through the transaction processing flow for HyperLedger. So that's what I'm going to try to do today, is I want to kind of try to get you to understand basically how the transactions work in HyperLedger. So when we're in a HyperLedger environment, we probably already understand that we have peers and we have kind of a membership services, and then we kind of have those peers within each network kind of run the ledger and the log files. And so in essence, that's what we see here is we see that we have a peer that's running, kind of a ledger here that's keeping track of all of the transactional data or all the changes to the data for our application. And then we have our chain code that is running up here, which is on that peer as well. And you can think of the chain code as just like the code that you might have in an existing application. So when you have an existing application, you have your code that kind of handles, kind of the logistics. And then you have your content, which is the actual data that the individuals are putting in. So you can kind of think of that the same way here. So we have our peer that has our chain code, and then we have our ledger. Cool. Excuse me. And so we go down here and we look at, kind of some of these different scenarios and some of the relationships that you would have. A peer might have relationships with different entities and different channels, and each channel will have its own chain code and its own ledger. And so that's kind of what they show here. But let's just go ahead and kind of keep it simple. So we're going to have just basically one network, and then we have one peer here within that network. But if we had multiple peers, each peer would have their own chain code and their own ledger that they would replicate amongst themselves, and then they would share an ordering node within that particular network. So each network has their own ordering node, each peer has their own chain code and their own ledger. Cool. And then we have our network here that kind of has the different peers that are involved within that payment channel. Cool. And then we have, of course, the applications that will interact with it. And that's what we see externally of the network that's coming into the peers. So that's going to be exposed through, I believe, a REST API, and that's how we'll actually get connected to that particular peer. All right, so that's how we're going to connect through our application. And then that application, of course, is going to invoke chain code through function calls, right? And so let's go ahead and just take a step back before I kind of walk through that with you. But let's take a look at this for a second and kind of think about what is the reasoning behind some of the scalability for transaction per second, or the amount of volume that you can put through or your throughput for your transactions. So when we start thinking about that throughput or the amount of transactions per second, we see a lot of public blockchains struggle with that. And so on a private blockchain, I want to kind of expand on why that's easily handled, and it's much because of this ordering node, because we have this ordering node and the method that the application is sending the transactions into the peers. It gives those peers the ability to perform transactions in parallel while allowing the ordering node to serialize those transaction process flows. So the ordering node is kind of responsible for putting the transactions in the correct order to ensure that we don't have the double spend problem that we always are concerned with. Cool. So that's really in essence what that ordering node's doing for us. And in essence, and like I said before, it allows us to do parallel processing, and then that parallel processing gives us much more throughput. Sweet. So if we walk through this and we kind of just look, so let's say we have an application, let's say if it's like the perishable network that we use quite a lot when we talk about HyperLedger, where we have perishable produce that we're shipping in a supply chain, and we want to, let's say for instance, track variables that are going on within that shipment based on some type of a sensor that might be shipped with that sensor, with that with that produce. So with that said, then we could have a sensor, a smart sensor in our produce shipment that's sending information through various different key stations and reporting on that information from each of the handlers about the conditions that have occurred for that shipment. And so then we could have auto execution that's going to automatically, let's say for instance, pay out on this transaction once that transaction reaches the next waypoint. And so with that being said, pretty easy solution, pretty simple to follow. Let's say, for instance, if we're going to do that here. So let's say this is our application out here that just needs to report this information. And let's say that it's collected some information from some of our smart tags, and now it needs to report that through this Raspberry Pi. So this Raspberry Pi is maybe going to make an enclave connection to a peer, which is in essence going to ensure that that Raspberry Pi is authentic. And it's going to do it through, that secure enclave connection. And so if you're not familiar with that, I encourage you to check that out. It's pretty cool. But anyway, it's going to make that connection, and then it's going to, once it makes the connection to the peer, it's then going to invoke the chain code proposal. So it's going to say, hey, call this function to, let's say, for instance, report the temperature of the shipment and the time and the location. GPS location, temperature, all that stuff. We're going to report that onto the blockchain. Cool. So we want to invoke the chain code to do the setter functions for all of that variable information that we just pulled in from that IoT device. So we're going to invoke that chain code with that proposal. The chain code is going to generate a query and update that proposal response onto our ledger. At that point, the peer is then going to send that proposed response back to the application, and then the application is then going to request that the transaction be ordered through the ordering node. After the transaction has been ordered, it's then going the order is going to be going to place the transaction in a block and then send that block back to the peer to then be, of course, placed into a block onto the ledger and or the distributed ledger that we have amongst all the peers in that payment channel. And now we have a completed transaction in essence. So the peer updates the blockchain ledger with the transaction block, and that's pretty much it. The peer will then get an update event back to the application, notifying them that the transaction was successful. So in essence, that's what's going on here. It's pretty simple, pretty easy walkthrough. But I had a couple people asking questions about it, so I want to make a quick video, just kind of walk you through that. And I think I'm going to do one for the Ethereum one too. So I know I posted the Ethereum kind of virtual machine architectural diagram, and that's really confusing for a lot of people. So I think I'm going to do one of those. Hopefully I'll get that done today. If I don't get it done today, maybe I'll get it done next week. So anyway, hopefully you guys enjoyed this. If not, let me know. If I messed anything up, let me know too. I'm a little new to HyperLedger, so so again, please forgive me if I messed anything up. So cool, awesome, thanks. Oops.